I'm going to teach you guys the most advanced and misunderstood feature in all of geology. It's called flames, and in many cases it looks like a perfect set of barreling waves. They can be very small or very large. That's my 11-inch rock hammer for scale. This same formation can be found in the clouds. Understanding fluid motion can show us exactly how these geologic flames formed. And it's nothing like the consensus. In fluid dynamics, these are called coherent structures. In this experiment, nitrogen gas is flowing on the bottom, and lighter helium gas is flowing faster on top. The difference in flow speed and friction between the two fluid layers causes a vortex to roll along the boundary. This creates an interaction that looks exactly like a barreling wave. So as these sandstone layers were settling and still had plenty of water in between the grains, this barely suspended sediment acted like a heavy, viscous fluid. The upper layer was more suspended and was more affected by the ocean current above it. Same with the atmospheric current flowing above the clouds. So what's the geologic consensus then? It's from a pre-existing weak point on the lower layer, and then pressure from above pushes up the flame somehow. The first problem is that sediments settle very uniformly underwater. The second is that the pressure from above is also very uniform. A flame would not rise because it is experiencing just as much downward pressure as the weak point, which would just sink a little. This also doesn't explain the consistent direction and barreling wave shapes of the formation. Now, there are flames that are not directional and they actually look like flames. So how did these form then? Well, if you look at this example, below it you can find smaller flames pushed in the opposite direction. This indicates chaotic currents during deposition. So while the flame is forming, if the current direction reverses, then the crest will be pushed back the other way, creating a squiggly crest that looks like a flame. These perfect examples of coherent structures are found in Point Fermin, California. And this outcrop has layers of breccia above and below them. These breccia layers are made of ripped-off chunks of sandstone and were deposited in a different sandstone layer. It takes a fast current to hydraulically pluck the sandstone off its original layer, to transport it and then deposit it in a sequence of new layers. This whole outcrop at Point Fermin paints a picture of extremely fast ocean currents in rapid deposition. Great examples of breccia are found in San Diego, and flames can be found there too. The largest flame structure I've seen is on the Central Coast, and it is about 2.5 feet tall. Layers of fossilized kelp can be found here. The kelp was preserved before rotting because of the rapid deposition of this event.